Hi, my name is Winso, and today I'll be explaining my ARM assembly code for bubble sort algorithm that stores the sorted input data into the output data. So at first I initialized R1 register as 32, which is the initial length of array. And you can see that it's updated right here. And I store the address of input data into R0 and address of output data into R6. It's updated right here. And I initialize R2 as 0, which will be used as a flag to check if any swap happened during the loop. R5 register will be used to keep track of loop count. So inside the inner loop, for every iteration, we want to increment the loop count by 1. And in this address, I decided to increment the address of output data by 4, just to keep it aligned with the address of input data. So in here, we want to load the first data from the input data address to R3 and increment the input data address by 4. So the first data of input address is 2, so R3 should be updated by 2, which is correct right here. And this incremented the input data address by 4, so which is the next index of the array, 0. So we want to store 0 in R4, and we can see that R4 is updated with 0. Now we use the compare instruction to compare the first data and second data, and updates the NZZB flags accordingly. And in the next instruction, we want to check the condition for a branch. If the first data is less than or equal to the second data, meaning we don't have to do any swapping, we just move on to the next element in this next tag right here. But since 2 is not less than or equal to 0, we have to do the swapping. So we store the second data into the initial address. If you see in here, the second data is 0, we want to store it in the initial address, so this should be updated to 0. And the first data 2, or 32, is to be stored in the next index, which is right here, so it will be 2. We want to repeat the process to output data, and if we see the output data right here, it's 0 and 2, so it's updated correctly. And since a swap happened during the loop, we want to update R2 by 1. And next, we want to compare the loop count and current array length. So if loop count is less than the array length, then we branch back up to inner loop. And this repeats until we iterate through the whole array. And if that happens, right here, we just want to compare the R2 or the swap flag to 0. So if it's equal to 0, it means that the whole array is sorted, so no swap occurred. So we just want to exit the program. But if a swapping occurred, it means that we have to go back to the first index. So we want to subtract R1 or the initial array length by 1 because the last element is already sorted. And we want to branch back up to the outer loop. So it resets the R0 as in address of input data, R6 as the address of output data, and the swap flag as 0, and the loop count is reset to 1 again. And this repeats the process until the whole array is sorted. If we look into the output data address inside the memory, we can see that the datas are sorted accordingly from -16 to +15. So this concludes the bubble sort algorithm.